All right, we're going to look at a couple of application problems on the back side of our notes here, on the second page of our notes. First one is related to some bacteria that are growing on the handle of our classroom pencil sharpener. Gross, man. Wash your hands this time of year. It's really yucky out there with our number of colds and the flu's going around. So wash your hands, everyone. At 7 a.m. there were 8 bacteria on the handle. At 8 a.m. there were 12 bacteria. And at 9 a.m. there were 18 bacteria. Let's fill out a table and start to model this situation. So to make it a little bit easier, we're going to say 7 a.m. is like our starting amount where 0 hours have passed. So then at 8 a.m., 1 hour would have passed. At 9 a.m., we're 2 hours into it. And then at 10 a.m., we're at 3 hours into it. That's going to make our modeling of this situation just a little bit easier to think of it as the number of hours that have passed when we're plugging in numbers. So we are told that we have 8 bacteria, and then after 1 hour we have 12, and after 2 hours we have 18. And I think that is all we have, right? So if this is an exponential growth problem, well, actually if it's an exponential problem, we can see that the numbers are growing, right? And so if we think of the growth factor here by taking the second divided by the first, that's going to be 1.5. Let's just double check. Do we have that same growth factor here? 18 divided by 12 is also 1.5. Okay, good, because we need to have that same growth factor between every y value here. So we are multiplying by 1.5, multiplying by 1.5. So 18 times 1.5 is 27. And so on and so forth. So we multiply by 1.5 each time. And once again, this is an exponential growth problem then. So exponential growth, because our numbers are increasing by the growth factor of 1.5, by the multiplier of 1.5. I'm actually going to come back to the graph here because I feel like we need a little bit more information about our number of bacteria before we start making a scale over here, especially on our y-axis. So I realize it says b there, but I'm going to come back to that. So think about our equation right here. We have y equals our beginning amount, our starting amount, our y-intercept of 8 times our growth factor of 1.5 to the power of x. So that's now the equation that we can use to model the situation. And then the next question is, how many bacteria will be on the handle at 3 p.m.? Okay, so let's think about how many hours would have passed. At 10 a.m., 3 hours had passed. That means at 11 a.m., 4 hours would have passed. At noon, 5 hours would have passed. At 1 p.m., 6 hours would have passed. At 2 p.m., 7 hours would have passed. And at 3 p.m., 8 hours would have passed. So that is what we're going to plug into our equation to figure out our number of bacteria. 8 times 1.5 to the power of 8. And let's see, I'm going to actually grab the calculator from over on the side here. And let's use that now. So we have 8 times 1.5 to the power of 8. And that gives us, can't quite see it there, can you? Oops, and now I lost it. And this is going really well. Here I thought I was being all techno-savvy, but really I'm just kind of a novice here. Okay, so that gives us 205 approximately bacteria. All right, I'm going to shrink that down there. Maybe that will help me. So thanks for bearing with us, everyone. So 205, approximately 205 bacteria. All right, so now we've gone from 27 up to 205. And then the next question is that during which hour will the number of bacteria pass 1,000? All right, so this is actually plugging in the 1,000 for the y value. And at this point, we haven't learned logarithms yet. And solving for this becomes a little bit tricky until we've learned how to do that. However, let's go back to our calculator because I still think we can manage this. We can certainly start just guessing and checking. All right, we can do that for sure. But here's what I'd like to do. Let's take and we can enter in our starting amount. And then what we can do is just take that last answer and multiply it by 1.5. And we get our 12. And then if we keep pressing enter, we can keep multiplying that by 1.5. So think about that. Now we're at 2 hours that have passed. These numbers should look familiar. Now we're at 3 hours that have passed. 4 hours have passed. 5, 6, 7, 8. And there's that number that we had from the last problem. So 8 hours have passed. 9, 10, 11. And by the 12th hour, so between the 11th and 12th hour, we have crossed over that 1,000 bacteria threshold, so to speak. So I'm going to say between 11 and 12 hours. Okay, so what time would that be? Let's think about that. So at 3 p.m. it was 8 hours. So 4 p.m. would be 9 hours. 5 p.m. would be 10 hours. 6 p.m. would be 11 hours. So we're talking about between 6 p.m. and 7 p.m. then is when we've crossed that 1,000. So we've gone from 8 all the way up to 1,000 in that amount of time, in about 11, 12 hours. And this is going to keep going up faster and faster and faster now. So now let's come back to our graph. Time passed, and then we're going to write number of bacteria. And let's think about a scale here. And so, oops, we got 0, and then we got 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8, 9, 10. And then we have the number of bacteria. So let's see. We were getting up close to that 1,000 amount very quickly here. So what if I went by 50s here? 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550. Okay, well that doesn't quite get me to that last hour that we were talking about, but I think it does get us pretty close, gives us a good picture of the graph still. So let's go ahead and go by 50s. All right, feeling like I need to change color here. Why don't we graph our points in red here? So we started off with 0, 8. So our starting point, so we'll have to estimate that. 0, 8, so at 7 a.m. there were 8. And then 1, 12. Okay, so you're not going to be able to really even tell the difference here between 8 and 12 with a scale like this. But eventually that will help us out. So then at 2 hours, we're at 18. So we're still, just barely growing here according to our scale. And 3 hours, we're at 27. Well, that's basically halfway up to 50. Okay, and that's when our table stops. But now let's go back to our calculator and see if we can start filling in some values with our calculator here. So let's clear that again and start thinking about, okay, 8 and then times 1.5. All right, 27, 40.5, 60.75, 91. We could also have made this table on our calculator as well. So a couple options for us here. And some of you guys might be saying, why didn't you just put it into the table feature on your calculator, the y equals? Yes, could have done that. Didn't, choosing to do it this way. So thanks for bearing with me. So after 4 hours then, we're at 40.5. So we're getting close to that 50. And then after 5 hours, lost the calculator. We're at 60.75 and then 91.25. So now we're starting to grow a little bit faster and faster. Okay, then we're at 137.205 and 307. So 137.205. And 307. So I think I've clicked back and forth between that enough to, and I think we have enough of a picture now so that we can start to see what is happening now with our exponential growth. Right. Started slow at first, but it obviously is picking up speed now, so it's getting faster and faster and faster, and going higher and higher and higher. And by tomorrow afternoon, there's going to be so many bacteria that we have a situation on our hand. And hands, no pun intended.